Hello everyone, welcome to NumPy for Data Analyst course. So in this course we will learn the basics of NumPy for Scratch and provides background information on how to NumPy works and how it compares to Python's built-in list. So this course goes through on how to write code with NumPy, especially for data analyst. So it starts with the basics of creating arrays and then gets into more advanced stuff. So this course covers creating arrays, indexing, statistics, other professional algorithms using math, reshaping and much more. And you can also go through to these material for better understanding, which containing some books and self-paced learning platforms for practice and also some research articles and papers. So let's start with my introduction. I am Hafiz Attaullah. I am a telecommunication engineer, MVP and ambassador at deeplearning.ai and section lead at IEEE Extreme, Microsoft Certified Trainer, Cisco instructor and also SME at Certiproof and former Google DSC lead. And my areas of interest and expertise are multi-cloud infrastructure, SecOps and federated learning with deep learning applications. And you can contact and reach me through these handles. Gets started with NumPy introduction. Basically, NumPy numerical Python is an open source Python library that is used in almost every field of science and engineering. It is the universal standard for working with numerical data in Python, and it is the core of the scientific Python and PyData ecosystems. As you know, NumPy users include everyone from beginning coders, beginners to experienced researcher doing state-of-the-art scientific and industrial research and development. So the NumPy API is used extensively in Pandas, SkyPy, Matplotlib, and scikit-learn, images, and most other data science and scientific Python packages. The NumPy library contains multi-dimensional arrays and matrix data structures. You will find more information about this in the later sections. And also it provides ND arrays, homogeneous and dimensional array object with the methods to efficiently operate on it. Also, NumPy can be used to perform a widely variety of mathematical operations on arrays, and also it adds powerful data structures to Python's data that guarantee efficient calculations with arrays and matrices, and it simply supplies an enormous library of high-level mathematical functions that operates on these arrays and matrices. So to install NumPy, we strongly recommend using a scientific Python distribution. If you are looking for the full instruction for installation NumPy on your operating system, you can search this with NumPy official website. Yeah, www.numpy.org. Okay, so if you are already have Python, you can install NumPy with cmd using these two commands, conda install NumPy. Okay, so also you can use pip command, simply pip install NumPy. This is updating now. or you can use pip command for installation. Pip install numpy. But if you don't have Python yet, you might want to consider using Anaconda. Uh, so using Anaconda, it's the easiest way to get started. And the good thing about getting this distribution is the fact that you don't need to worry too much about the separately installing NumPy or any of the major packages that you will be using for your data analysis, like Pandas, like other data science libraries. So for Anaconda, you can simply go to Anaconda website, and you can download this. You can download this as your operating system. Now get started with our first NumPy program. So first of all, you have to create your first new notebook with Python 3 with Jupyter notebook, means Anaconda. So first of all, to access the NumPy and its function, you have to import it in your Python code. Simply you have to import NumPy as np. So run this code. That means we shorten the imported name to np for better readability of code using NumPy, and this is a widely adopted convention that you should follow so that anyone working with your code can easily understand it. So you can also rename your notebook. I am typing as importing and reading the code NumPy. Rename this. Okay. Now if you are not already comfortable with reading tutorials or watching videos that contain a lot of code, you might not know how to interpret a code block that looks like this. So simply I am texting some code so that I can show you some of examples. So if you are not familiar with this style, it's very easy to understand. If you use this interpreter, you are looking at input or the code that you would enter, and everything that doesn't have this interpreter in front of it is output. Like I'm running this code, so that means everything that doesn't have the interpreter in front on it, that is output or the result of running your code. So this is the style you see when you run the Python on the command line, but if you are using IPython, you might see a different style. Now difference between a Python list and a NumPy array. So NumPy gives you an enormous range of fast and efficient ways of creating arrays and manipulating numerical data inside them, while a Python list can contain different data types within a single list. All of the elements in a NumPy array should be like homogeneous. So the mathematical operations that are meant to be performed on array would be extremely inefficient if the array were not homogeneous. So NumPy arrays are faster and more compact than Python list, and arrays consumes less memory and is convenient to use. And also NumPy uses much less memory to use store, and it provides a mechanism of specifying the data types. This allows the code to be optimized even further. Now, what is an array? So, an array is a central data structure of the NumPy library, and it is a grid of values, and it contains information about the raw data. So it shows that how to locate an element and how to interpret an element, and it has a grid of elements that can be indexed in various ways, like we can use in one dimensional array can be indexed and much like list and other Python sequence. Like I am creating an array like a is equal to np dot arrange of 10 power 3. It shows the 0, 1, 8, 27, 64, 125, and so on. So if I am indexing operation on this array, that means a of 2 means 8, because it starts with 0. Okay, so like a 2 colon 5, it starts with 8 to 27 to 64, and it equivalent to a 0 colon 6 colon 2 is equal to thousands. And also when shows 1000, 1027, and it indexed anti-reversed. Okay, so also we can use this in this operation as for loop and other loops. Now this example is based on multi-dimensional array, that is basically have one index per axis, and these indices are given in a tuple separated by commas. So basically the elements are all of the same type, referred to as the array's D type. So we can say that an array can be indexed by a tuple of non-negative integers by you can see here by boolean, by another array, or by integers. And the rank of array is the number of dimensions, and the shape of the array is a tuple of integers giving the size of the array along each dimension. So in basics, one way we can initialize NumPy arrays is form of Python list using nested list or 2 or higher dimension data. For example, I can create a array is a is equal to, for suppose, np dot array of run this code. So as we can see, this is one dimensional array. We can also use as two dimensional array, as you can see. So in summarize, we can access the element in the array using square brackets when you are accessing element. And remember that indexing is NumPy starts at 0. That means that if you want to access the first element in your array, you will be access in element 0. So say for example, I can print So this shows 1, 2, 3, 4. That means first row. Now you might occasionally hear an array referred to as a ND array, which is a shorthand of n-dimensional array. So basically an n-dimensional array is simply an array with any number of dimensions. You might also hear 1D or one-dimensional array, 2D or two-dimensional array, or so on. So the NumPy ND array class is used to represent both matrices and vectors. And the vector is an array with a single dimension, means there is no difference between row and columns vectors. But while a matrix refers to an array with two dimensions for 3D or higher dimensional arrays. So the term tensor is also commonly used for this. I can tensor, yeah, this tensor. Okay, so an array is usually a fixed size container of items of the same type and sizes, and the number of dimensions and items in an array is defined by its shape. And the shape of an array is tuple of non-negative integers that specify the size of each dimension. So in NumPy, dimensions are called axes, and this means that if you have a 2D array, this is 1D and this is 3D, and if you have a 2D array, that looks just 1 2 3 4 to 5 6 7 8. If you have a 3D array, that looks like this, completely looks like this. So your array has two axes. The first axis has a length of 2, and the second axis has a length of 3. Just like in an other Python container objects, the contents of an array can be accessed and modified by indexing and splicing the array. Unlike the typical container objects, and different array can be share the same data, and so changes made on one array might be visible in another. So array attributes reflect information intrinsically to the array itself. If you need to get or even set properties of an array without creating a new array, you can often access an array through its attributes. Okay, so we are gonna start with basic operations on array. So basically, to create a NumPy array, you can use the function of np.array, as I mentioned in previous video. So all you need to do is to create a simple array is pass a list to it, and if you choose to, you can also specify the types of data in your list. And you can find more information about data types from this article. This is basically a NumPy official article based on data type objects, that is basically also called as a D type. That is basically contains some of examples, like contains 32-bit integers, and also some floating values and characters and other some specific values. So I personally recommend you to refer this notebook also. Okay, so let me rename this notebook sheet 2. Okay, so first of all, I simply import the NumPy and creating a simple array. let me check. Okay, so you can visualize your array this way. I mean to say in this way. Okay, so basically beware that these visualizations are meant to simplify ideas, okay, and give you a basic understanding of NumPy concepts and mechanics. Also arrays operations are much more complicated than are captured here, you know. And besides creating an array from you know, a sequence of elements, you can easily create an array filled with zeros, like np dot zeros with like 2 or 3, you know, about as you are. So let's say array 0 dot comma 0 dot also, or an array filled with ones also, you know. Simply you can edit this zeros as ones. Simple. Run this. Yeah. Or even an empty array you can use as empty array. So I can say basically this function empty creates an array whose initial content is random and depends on the state of the memory. So the reason to use empty over zeros or something similar is speed minus just make sure to fill every element afterwards. So I can say that like create an empty array with 2 elements. So that is basically np dot empty of 2. So the reason to use this empty over zeros is speed minus just make sure to fill every element afterward. This is the main. And so you can create an array with a range of elements. So you can use np dot arrange this function like 4 or something else. Okay, and even an array that contains a range of you know, evenly spaced intervals. So to do this you will specify the first number and last number and the step size. So simply you have to edit this and with 2, for say for example 2 9 and something 2. So the first 2 is for first number and it's the last number, and step size 8 is the step size. Also you can use np linspace to create an array with, you know, values that are spaced linearly in a specified internal and, you know, in basically intervals. So what you have to do is you have to use linspace with the index of 0 comma 10. Say for example I can put a function, a variable that is 5. Okay, so yeah, like this. So now we are moving to specifying your data type. So while the default data type is floating point, like np dot float 64, that is basically the type of floating 62 bits, you can explicit specify which data type you want to using the D type keyword. So you have to do it like x is equal to, for say for example, numpy ones of 2, and with the D type of, say for example, np with integer of 62. You can use the float value, and you can either use integer. Okay, so simply, yeah. Now come to shooting and concatenate. So as you know, shooting is an element that is simply with used as np.sort, like using this. Okay, so you can specify the axis, you can specify the kind, you can specify the order when you call the function, you know. So if you start with the array, like I am starting with array is equal to say for example array array of 2 1 5, like 3 and 7, and also we have 4 6 and also 8. So you can quickly sort this. The number is ascending order with 1 minute. Okay, so you can quickly sort. The number is ascending order with np sort. So yeah, as you can see, this is ascending order 1 2 3 4 5 6 7 8. So in addition to sort, which returns a sorted copy to an array, you can use the some of arg sort, argument sort, and also you can use lex sort. Another is search sorted, and also you can use partition. So to read more about sorting, you can use this sheet as for example numpy.sort of a comma axis is equal to -1, and kind is equal to none, order is equal to none. So basically first parameter is array. This is array to be sorted, means this can be axis, is not or none. That is optional for you. So basically axis along which you sort. If none, the array is flattened before sorting, so the default is -1, would sort along the last axis. Also you can use the kind, that is basically third parameter. So this is sorting algorithm, and the default is quick sort, not that both stable and you know uh, merge sort. Use the time sort of radix sort under the covers, and in general the actual implementation will vary with data type. So you can also refer this args sort, and that is basically indirect, and lex sort, again indirect stable sort on multiple keys. Search sorted, that is basically find elements in a sorted array, and again partition partial for partial sort. You can use this source code too for shooting. Yeah, from this is basically an actual guide from NumPy for shooting methods and shooting algorithms, uh, using for machine learning, data scientists, and also for data analysis. So now if you start with these arrays, like if you can use this using this, you can concatenate them uh, with the function of this, using like np dot numpy dot a comma b. So in order to remove elements from an array, it's simple to use indexing to select the element that you want to keep. Now, how do you know the shape and size of an array? So in this section, we are gonna cover the all size and shape arrays, which are, so first one is ndarray.ending. This one is basically, I am just writing this, and okay, so this will tell you the number of x's or dimensions of the array. Remember this. And also you can add it with this size, and this will tell you the total number of elements of the array, and this is the product of the elements of the array shape. And also you can use as this function as shape, and this will display a tuple of integers that indicate the number of elements suited along each dimension of the array. So if for example you have a 2D array with 2 rows and 3 columns like this, so the shape of your array is 2 by 3, right? So say for example I am just writing as dot ndim, yeah, 3. So this 3 is the number of axes or dimensions of the array. And also you can use the size as like say for example size 24. So this tells you that total number of element of the array, and this is the product of the element of array shape. And also we have an example of shape. So say for example so this displays the tuple of integers that is indicate the numbers of element stored along each dimensions of this array. So if for example this have the 2 by 3 array, so this will equal by 3, 2 and 4. Now the question is, can you reshape this array? Yeah, uh, the answer is yes. So we can reshape an array using arr.reshape function that will gives a new shape of an array without changing the data. And just remember that when you use the reshape method, the array you want to produce needs to have some number of elements as the original array. So if you start with an array with, for example, 12 elements, you will need to make sure that your new array also had a total number of 12 elements. So if you start with this array, like say for example a is equal to so if you start with this array, you can use the reshape for this for to reshape your array. For example, you can reshape this array to an array with 3 rows and 2 columns. So just use the reshape function with 2 by 3, 3 by 2, and simply print this function with b. With this function you can specify a few optional parameters too, like when you use this numpy, for example numpy.reshape of, these are the optional, you can either use or not. New shape is equal to what, for say for example 1 and 6. So with the order of C. Okay, so basically A is the array to be reshaped, and basically reshape is a new shape you want. You can specify an integer or a tuple of integers, and if you can if you have specify an integer, the result will be an array of that length, and the shape should be compatible with the original shape. And order C, that is order C means to read and write the elements using C like index order, and F means to read and write the element using Fortran like index order, and A means the A means to read and write the elements in Fortran like index order in if a Fortran contiguous in memory. So C like order, otherwise this is an optional parameter and doesn't need to be specified. So essentially C and Fortran order have to do with how indices correspond to the order the array is stored in memory. So in Fortran, when moving through the elements of a 2-dimensional array as it is stored in memory, so the first index is the most rapidly varying index. As the first index moves to the next row as it changes, and the matrix is stored one column at the time, and this is why Fortran is thought of an column major language. So in C, on the other hand, the last index changes the most rapidly, and the matrix is sorted by rows and making it a row major language. So what do we for C or Fortran depends on whether it is more important to preserve the indexing convention or not recorded the data. So now how to convert a 1D array into 2D array. That means how to add a new axis to an array. So in this section we will cover NP new axis and expand dimensions. So you can use NP new axis and expand dimensions is to increase the dimensions of your existing array. That means you have to convert 1D array into 2D array. So using NP new axis will increase the dimensions of your array by one dimension when used once. This means that a 1D array will become a 2D array, and a 2D array will become a 3D array, and so on. A 4D array to become 5G and 6G and D and so on. So for example, if you start with this array, this example, so I'm running this, and just you have to reshape this. For example, a shape that will equal to 6 comma and something. 1 minute, yeah. Okay, so now you can use new axis to add new axis. Now you have to new axis command for this example. So say for example I am adding this, and again reshape this A2. Okay, so you can explicitly convert a 1D array with either a row vector or a column vector using NP new axis. For example, you can convert a 1D array to a row vector by inserting an axis along the first array. So for example, okay, so we have converted a 1D array to a row vector by increasing an axis along the first dimension. So now for a column vector, you can insert an axis along the second dimension. For say for example, I am using the same example for this too with the help of column vector. Okay, say for example col vector, and also I am using the colon on, yeah. So as you can see, column vector is inserted an axis along the second dimension. Also you can also expand an array by inserting a new axis at a specified position with the expand dimensions. So for example, we have again same example, a is equal to 1 2 3 and 6, and shape is also the same. So run this, and now I'm using the np.expand dimensions command to add an axis at index position 1 with, for example, b is equal to So as you can see, I'm added an axis position with 1. So now indexing and slicing. As previous video, we have discussed how to convert a 1D array into 2D array. That means how to add a new axis to an array. So now we are going to discuss the indexing and slicing, that you can how to index and slice numpy arrays in the same ways you can slice Python list. So as you can see here, you can, if you are running this, sorry, okay, if you can index and slice this numpy array, you can see this is the same way you can slice Python lists. Also you can visualize in this way, that 0 means 1 and 1 means 1 slice means 2, 2 means 3. If you are if we are going with 0, that means 1, 1 means 2, and 0 colon 2 means 0 to 2 means 1 to 2. Okay, and 1 colon means 2 to all, 2 to all means 2 and 3. In this case 2 to 3. If we have if we are have value of 1, 2, 3 and 4, then it will be 2, 3 and 4. Also data minus 2 is 2 and 3. So you may want to take a section of your arrays or a specific array element to use in further analysis or additional operations. To do that, you will need to subset, you need to slice, and or you can use index your arrays. So if you want to select values from your array that fulfill certain conditions, it is straightforward with Python. For example, if you start with this array, for example, run this code, and we have 1, 2, 3, 4. Okay, that means we can easily print all the values in the array that are less than 5. Also you can select, for example, number that that are equal to or greater than 5 and use that condition to index an array. Then it will be equal to 5 to 12. That means that are the numbers that are equal to or greater than 5, and use that condition to index an array. Okay, so now also you can select all the divisible elements by 2. So run this code, all the elements that are divided by 2, that can be divided by 2. Or you can also select element that satisfy by 2 conditions using the and or operators. So yeah, 3, 4, 5, 6, 7, 8, 9 and 10, these are the values that satisfy 2 conditions using and using or operators. Also you can also make use of logical operators and or operator in order to return boolean values that specify whether or not the values in an array fulfill a certain conditions. So this can be useful with arrays that contain names or other categorical values. So say for example, I am running this code, this tells false, 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 first condition, then true, true, true and true, true, true. Next is you can also use np non-zero function to select the elements or indicates from an array. Say for example, starting with this array, run this, and we have to np non-zero to we have to use this function to print the indices of element that are less than 5. Okay, so we can see these all are the less than 5 elements. In this example, a tuple of arrays was returned, means one of each dimension. The first array represents the row indices where these values are found, and the second array represents the column indices where the values are found. Now, if you want to generate a list of coordinates where the element exists, you can zip the arrays. So iterate over the list of coordinates and print them. For example, yeah, that means you can zip the arrays. Means iterate over the list of the coordinates and print out the coordinate. Now you can also use np non-zero to print the elements in an array that are less than 5 with this command simply. Yeah, less than 5 means before 5 values 1 2 3 and 4 in with this example. Okay, now so now if the element you are looking for does not exist in the array, then the returned array of indices will be empty. For example, I am using this function, so yeah, this will empty and again this empty array. Okay, now basic array operations. So this section covers addition, subtraction, multiplication, division, broadcasting, and some other basic operations of array. So once you have created your array, you can start to work with them. So let's start with that example that you have let's say that you have created two array, one's called the data and one's called ones. So you can add the array together with the plus. Okay, so say for example, in this example, just I am adding these arrays together with the help of plus sign. Yeah, and show these this same example in this graphical form. Okay, so now also you can of course you can do more than just addition, like subtraction, division, and addition and others. So just run this. Yeah, in graphical form, data and ones minus 0 1 and again 1 into 1 2 into 2 4 and again 1 divided by 1 1 2 divided by 2 is 2. So basic operations are simple with NumPy. If you want to find them some of the element in an array, you would use sum command, this sum command. Okay, so this works for 1D array, 2D array, and arrays in higher dimensions. Like I'm running this, 10. So 4 plus 3 plus 2 plus 1, that is equal to 10. And to add the rows or the columns in 2D array, you would specify the axis. So if you start with this array, then you can sum over the axis of rows with the help of this 0. So yeah,
Okay, so also you can sum over the axis of columns with this example. You can run this again, means 2 4. Now broadcasting. So there are times when you might want to carry out an operation between an array and a single number, that is also called an operation between a vector and scalar, or between arrays of two different sizes. For example, your array, we will call it data. Array means data in this example. Your data might contain information about distance in miles, but you want to convert the information in kilometers. You can perform these operators using this command. So run this. Yeah. That means NumPy understand that the multiplication should happen with each cell. That concept is called broadcasting. Means broadcasting is a mechanism that allows NumPy to perform operations on arrays of different shapes, and the dimensions of your array must be compatible. For example, when the dimensions of both arrays are equal, or when the one of them is ones. If the dimensions are not compatible, you will get a value error, as you can see in in this example. There is no error in this example.
Okay, so now we are gonna creating some matrices using NumPy. So as we know, we can pass Python list of list to create a 2D array, or we can say 2D array means a matrix, to represent them in NumPy as NumPy, uh, assigning the NumPy function, then simply 2D array assigned. You can run this. Yeah. Also, you can see indexing and slicing operations are useful for this. So let's move on indexing and slicing. So basically, indexing and slicing operations are useful when you are manipulating the matrices. So as you can see in this example, uh, also you can see in graphical form that we have data of 2D matrices, then index of data 0 comma 1. 0 means row and 1 means column. So first row, second column. So also we can aggregate matrices the same way. You can aggregate vectors. So run this. Definitely this is gonna 21 and 1 and 6. So also you can see in this graphical form uh, the aggregation of this matrix is 6 and 1 and 21. Now you can aggregate all the values in a matrix, and you can aggregate them across columns, or across the rows, using the axis parameter, this axis parameter. So run this program. Yeah. As you can see that it uh, it aggregate them across columns and across the rows, because of this axis parameter. Now once you have created your matrix, uh, then you can add and multiply them using arithmetic operators. So if you have two matrices that are the same size, then you can uh, that is data and ones, for example. So run this program. Yeah. So you can add simply, you can multiply uh, both of the matrices. Also you can do these arithmetic operations on matrices of different sizes, but only if one matrix has only one column or one row. In this case, NumPy will use its broadcast rule for the operation, as we have discussed earlier in our previous section, like in this example. You can also see the same in graphical form. So, but uh, beware that when NumPy prints n-dimensional array, the last axis is looped over the fastest while the first axis is slowest. For instance, you can run this and yeah, like this. Okay, so yeah, there are often instances where we want NumPy to initialize the values of an array. NumPy offers to functions like ones function, zeros functions, some other built-in functions, and the random dot generator class of random number generation. For that, all you need to do is pass in the in the number of elements you want in generate. Say for example, in this case, we can run this, yeah, like this. This is because of random dot generator function. You can also see this or explore this in graphical form. And now you can also use ones and zeros and random numbers to create a 2D array if you give them a tuple describing the dimensions of the matrices, like ones, like zeros, and also uh, the random number. Also, you can see these all examples in a graphical mode. Uh, Also, you can generating a numbers, random numbers. Basically, the use of random number or generation is an important part of the configuration and evaluation of many numerical and machine learning algorithms and data analyst algorithms. Whether you need to randomly initialize weights in an artificial neural networks, or split data into random sets, or randomly shuffle your data sets, being able to generate random numbers actually, you know uh, uh, pseudo number random numbers is essential. So with generator integers function, i'm I'm just writing this. uh, yeah, this function. So this function, basically, you can using this function you can generate random integers from low. Remember that this is uh, inclusive with NumPy. So you can generate random numbers from low to high, and high numbers is basically exclusively. And you can also set the endpoints is equal to true or false or someone else to make the high numbers inclusive. Also, you can generate a 2 by 4 array of random integers between 0 and 4 and uh, others. Okay, so now we are gonna discuss about transpose and flipping on dimensional and multi-dimensional matrices. So basically, it is common to need to transpose your matrix. So NumPy arrays have the property T, T, that allows you to transpose a matrix. Like so you may also need to switch the dimensions of a matrix, like so you may also need to switch the dimensions of a matrix. So this can happen when, for example, you have a model that expect a certain input shape that is different from your data set. So this is where the reshape method can be useful. So you simply need to pass in the new dimensions that you want for the matrix. So simply run this code and okay, wait a second.
Okay, so so this model that expect a certain input shape that is different from your data set. So uh, can we use our simply need to pass in the new dimension that uh, uh, that now you can also use transpose function uh, to reverse or change the like. So now you can also use the dot transpose function for to reverse or change the axis of an array according to the values you specify. So if you start with this array, like we have array of this, run this array, and uh, transpose your array with this function. Okay, so this is the transpose result of this array. Also you can this simply t arr dot t, same results. Okay, now reverse an array. Basically numpy np.flip function that allow you to flip or reverse the contents of an array along an axis. When using np.flip, specify the array you would like to reverse the axis. If you don't specify the axis, numpy will reverse the content along all the axes of your input array. So we are working with reversing a 1D array. So if you begin with a 1D array, like we have this array, run this array and reverse it with this, print this. Yeah, so you can run this using print function, right? So according to me, a 2D array works much the same with with previously. So if you start with the array, you can run this first and you can reverse the content in all of the rows and all of the columns uh, with this. Okay, also you can easily reverse only the rows with this. Okay, or reverse only the columns. This is the result of reverse only for the column, or you can also reverse the contents of only one column or row. Okay, so for example you can reverse the contents of row at index position 1, then the second row is this. Okay, now you can also reverse the columns at index position 1, so the second row is basically like this. Okay, so now working with mathematical formulas. So the ease of implementing mathematical formulas that work on arrays is one of the things that make NumPy so widely used in the scientific Python community. So for example, this is the mean square error formula, uh, uh, a central formula used in supervised machine learning models that ideal with regression. So that is basically what is the idea behind this. Mean square error is equal to 1 upon n summation of y prediction minus y whole square. So implementing this formula in simple and straightforward in NumPy is basically this. Error is equal to 1 upon n into np dot sum bracket np square predictions minus labels. So what makes this work so well is that prediction and labels can contain 1 or 1,000 values. They only need to be the small size. You can visualize it this way. Error is equal to 1 upon 3 into np dot sum bracket np dot square, then predictions value 111 minus labels value 123 and so on. So basically in this example, both the predictions and labels vector contain 3 values, meaning n has a value of 3. After we carry out subtraction the values in the vector are squared, then NumPy sums the values and your result is the error values for the predictions and a score for the quality of the model. Like error is equal to 1 upon 3 into np dot sum square np into square and the result of this minus is 0 minus 1 minus 2. Okay, then again 0 1 and 4 again only 5 and error is equal to blah blah blah. So now how to save and load NumPy objects, how we can save the this objects and load the objects. So basically you will at some point want to save your arrays to disk and load them back without having to rerun the code. So fortunately there are several ways to save the load objects with NumPy. The ND array objects can be saved to and loaded from the disk files with load txt. I am also texting this load. Okay, also you can use the like save txt. Okay, these functions, basically these functions that handle normal text files, and load and save functions that handle the NumPy binary finals with the .npy file extension. So the .npy and npz file store data, shape, data and other information required to reconstruct the ND array in a way that allow the array to be correctly retrieved even when the file is on another machine with different architecture. So if you want to store a single ND array object, store it as .npy file. So it is easy to save and load an array with np.save function simply. Okay, so I am just this function. Okay, so just make sure to specify the array you want to save and file name.